My name is Albert Einstein. If you want to see me using AI, watch this video till the end. I was born on March 14, 1879, in the city of Ulm in the Kingdom of Württemberg, Germany. From a young age, I was a curious and inquisitive child, always pondering the mysteries of the universe. As I grew older, my fascination with mathematics and physics only deepened, and I knew that I wanted to dedicate my life to understanding the fundamental workings of the cosmos. My journey to uncover the secrets of the universe began with my education. I excelled in mathematics and physics, but despite my academic prowess, I felt constrained by the traditional teaching methods of my time. The rigid and rote learning in school stifled my creativity and hindered my quest for knowledge. In 1896, I enrolled at the Swiss Federal Polytechnic in Zurich, Switzerland, where I continued to study physics and mathematics. It was during my time at the university that I began to question the limitations of classical physics, particularly Newtonian mechanics. I wondered if there was a deeper reality beyond what was observable and explained by the existing theories. After graduating in 1900, I faced the harsh reality of the job market, struggling to find a suitable position in academia. I eventually secured a job as a patent examiner in the Swiss Patent Office, which, although not directly related to my passion for physics, provided me with the stability and time to pursue my scientific interests. During my stint at the Patent Office, I devoted my spare time to studying and formulating my own ideas about the universe. In 1905, in what would become known as my Annus Mirabilis, or miracle year, I published 4 groundbreaking papers that revolutionized the fields of physics and set me on a path to becoming one of the most renowned scientists in history. The first paper introduced the theory of special relativity, which proposed that the laws of physics are the same for all non-accelerating observers and that the speed of light in a vacuum is constant, regardless of the motion of the source or observer. This theory fundamentally changed our understanding of time, space, and the relationship between matter and energy, encapsulated in the famous equation E=mc². The second paper focused on the photoelectric effect, explaining that light can behave as both waves and particles, known as photons. This work laid the foundation for the field of quantum mechanics, challenging classical physics and paving the way for a new era of understanding at the atomic and subatomic levels. The third paper delved into statistical mechanics and provided an explanation for Brownian motion, the erratic movement of particles in a fluid. This work bolstered the evidence for the existence of atoms and molecules, which had been a topic of debate among scientists at the time. In my fourth paper that year, I introduced the theory of mass-energy equivalence, revealing the direct relationship between mass and energy, as expressed in the equation E=mc². This groundbreaking insight not only confirmed the energy locked within atomic nuclei but also opened the door to the concept of nuclear energy. The publication of these papers earned me recognition within the scientific community, and I was gradually offered positions at various universities. In 1909, I became a professor at the University of Zurich and later moved to the German-speaking University of Prague in 1911. Throughout these years, my research continued to explore the frontiers of physics, and my ideas evolved. However, it was not until 1915, while living in Berlin and working at the Prussian Academy of Sciences, that I formulated my theory of general relativity. This theory built upon the foundations of special relativity and introduced the concept that gravity is the curvature of spacetime caused by the presence of mass and energy. General relativity provided a more complete understanding of the universe on a cosmic scale, explaining phenomena such as the bending of light by gravity and the expansion of the universe. The idea behind general relativity came to me while pondering the problem of gravity. I imagined myself on a falling elevator, and it struck me that I could not differentiate between the force of gravity and the force experienced due to acceleration. This insight led me to propose that gravity and acceleration are fundamentally linked in the fabric of spacetime. After years of intense work and collaboration with fellow scientists, I finally published my theory of general relativity in 1915. The equations were complex and challenging to solve, and I faced skepticism and criticism from some members of the scientific community. However, subsequent observations, such as the bending of starlight during a solar eclipse, confirmed the predictions of my theory, and it soon gained widespread acceptance. My contributions to the field of physics continued over the years, and I was awarded the Nobel Prize in Physics in 1921 for my work on the photoelectric effect. Despite the recognition, I remained deeply committed to pursuing a unified theory that would unite the fundamental forces of the universe into a single framework. Unfortunately, the quest for such a theory, often called the theory of everything, would prove elusive for the rest of my life. As the years passed, I became an advocate for peace and social justice, using my platform and influence to speak out against the rise of nationalism and militarism in Europe. However, the political climate darkened, and the threat of World War II loomed large. As a Jewish scientist, I faced increasing persecution in Nazi Germany, and in 1933, I decided to leave my position in Berlin and emigrate to the United States. In America, I found a welcoming community and a new home at the Institute for Advanced Study in Princeton, New Jersey. It was here that I spent the final years of my life, continuing my research and collaborating with other brilliant minds. In the early hours of April 18, 1955, I passed away at the age of 76. Although my physical presence was gone, my ideas and contributions to science have left an indelible mark on the world. The legacy of my work continues to inspire generations of scientists, and my theories remain integral to our understanding of the universe. Looking back on my life's journey, I am grateful for the opportunities I had to explore the mysteries of the cosmos and to contribute to the advancement of human knowledge. My story is one of curiosity, determination, and the unyielding belief that the universe is governed by elegant and harmonious laws waiting to be uncovered by the human mind. As I said once, the most beautiful thing we can experience is the mysterious. It is the source of all true art and science. May my story serve as an inspiration for future generations of scientists and thinkers, encouraging them to embark on their own journeys of discovery and unlock the secrets of the universe that lie just beyond the horizon of our current understanding. I am Albert Einstein and this is my story. I hope you like it. Do not forget to subscribe my channel and thanks for watching.